Dam safety and rehabilitation engineering is the sub-branch of civil engineering branch which improve the safety and performance of selected existing dams and associated appurtenances in a sustainable manner. Prerequisites of dam safety and rehabilitation engineering. For pursuing masters in dam safety and rehabilitation engineering, one must have good grip on the following subjects during Bachelor of Civil Engineering: Engineering Geology, Water Resource Engineering, Geotechnical Engineering, Structural Engineering. Subjects for Masters in Dam Safety and Rehabilitation Engineering: Assessing and managing risks associated with dams. Study of various risks associated with dams and the techniques for dam safety assessment and management. Study of elements of the risk-based screening tool, brief reference to the hazard classification. Study of incremental risk concept, failure mode structure, risk model input data, levels of detail in risk calculation input data. These are the reference books. Basics of disaster management and its implementation concepts. Study of disaster management and implementation of various concepts to the dam by various modeling and mapping, etc. Study of damage survey for designing aid package, detailed survey for reconstruction, repair, and retrofitting, post-disaster survey, long-term measures, codal practices. These are the reference books. Hydrologic safety evaluation of dams. Study of hydrologic evaluations for dam safety. Study of moisture maximization factor, MMF, loss rate, base flow, time distribution coefficient, HEC-HMS model. Study of unit hydrograph, design storm, depth estimation from PMP Atlas, clock hour correction, aerial reduction factor. These are the reference books. Sediment management in reservoirs. Study of sedimentation in reservoirs, its assessment and measurement, various options to manage sedimentation of the reservoir. Study of weathering and erosion processes, sediment properties, modes of sediment transport, mathematical models. Study of sediment delivery ratio, rates of erosion and delivery, human impact on sediment yield, impact of natural events, measurement of sediment load. These are the reference books. Dam safety surveillance instrumentation and monitoring. Study of dam inspection, monitoring, etc., and explore the theory and practical knowledge for the dam safety surveillance instrumentation. Study of remotely operated underwater vehicles, ROVs, use of unmanned aerial vehicles, UAVs. Study of leakage, movement, types of movement, reservoir/tailwater elevations, staff gauge, precipitation, local seismic activity, stress and strain. These are the reference books. Seepage through dams. Study of basic principles and concepts of seepage and its control in dams. Study of Darcy's law, seepage velocity, Dupuyt's theory, seepage charts, phreatic lines, flow nets. Study of various dams and 6 adopt suitable measures for its safety. These are the reference books. Assessment and management of environmental issues in reservoirs. Study of ecosystem, environment, legal issues, guidelines, etc., and necessary practices and application on environmental issues in reservoirs. Study of agroeconomic issues, human health impacts. Study of sedimentation, nutrient enrichment, water pollution, emission of greenhouse gases. These are the reference books. Geospatial technologies for dam monitoring. Study of geospatial technologies in monitoring changes in geomorphological characteristics. Study of structural changes of dams and other hydraulic structures. Study of LIDAR data collection methods, application of LIDAR technology to dam monitoring. Study of GPS data collection techniques. These are the reference books. Engineering seismology and hazard analysis of dams. Study of engineering seismology, seismological instrumentation, reservoir-induced seismicity, seismic hazard assessment. Study of site-specific ground motion estimation, empirical Green's function. Study of domain method, boundary method and hybrid method. These are the reference books. Seismic safety of embankment dams. Study of earth and rock fill dams under seismic loads and their analysis using classical and contemporary approaches. Study of core, shell, cut-off wall, cut-off barrier, transition zones and transition filters. Study of seismic evaluation requirements, seismic input parameters for analysis. These are the reference books. Elective subjects. Geomechanics, ground improvement and geosynthetics. Sustainable tourism around dams. Design of hydromechanical components of dam. Earth retaining structures and dams. Some of the roles and responsibilities of dam safety and rehabilitation engineer. Make a comprehensive review of all data related to the dam. Making in-depth evaluations and arriving logical conclusions. Inspection as per guidelines for safety inspection of dams. Provide an expert opinion on safety conditions of the dam. Give suggestions for further improvement and rehabilitation requirements. Conducting dam safety evaluation. Investigating the dam hazards.